In data analysis, we often need to combine datasets for a more comprehensive analysis. Pandas provides powerful methods for combining datasets using concatenating, joining, and merging. Concatenation involves stacking datasets either vertically, row-wise, or horizontally, column-wise. It is useful when you need to combine datasets with the same structure. We will start by creating 3 data frames with sales data from different months. I'm just going to copy over these prepared data frames that I prepared. And so basically we have 3 data frames from 3 different months. So sales from January, February, and March. We have products, 3 specific products, and the sales for each product for each month. And we're going to provide specific indexes, which are going to be letters. So you could pause this video and copy over these values and we can continue on next. Once we've created our data frames, we could actually take a quick look at sales Jan, sales Feb, and sales March. So 3 just small basic data frames that we have of products for each month and the sales, and very simple. Now, let's say we want to concatenate these data frames vertically. So we can use the concat method or function, which is used to concatenate these data frames. And by default, it concatenates these row-wise. So let's do PD because this is a pandas specific kind of external function, not really built into the data frames, but it is a pandas method. So we do pd.concat, and here we will just provide a list of the data frames that we want to kind of concatenate or basically combine together. So we will do sales Jan, put this in order, sales Feb, and sales Mar. And then when we run this, we get one specific data frame that combines them vertically. So it stacks them on top of the other, and they have the same structure. So each data frame has a product column, each data frame has a sales column, and so we just stack them one on top of the other. Now we can also concatenate the data frames column-wise, so horizontally instead of vertically. And to do this, all we would have to do is add a parameter here called axis equals 1. So this basically says that we want to do this horizontally instead of vertically. And so when we run this, we add each data frame next to each other. Rather than on top of each other, we add them next to each other, one after the other. Now, as you can see here, this combines the data frames side by side. If the index values don't match, Pandas fills in the missing entries with nan. So in this case, the second data frame does not have an ABC index. It only has a DEF. So only in the DEF rows, it would add these 3 values. So it's its own values. So because it doesn't have an ABC index, it fills them with nan. And similar with the third data frame, it does not have a GHI index, so it fills those with nans as well. So everything else that it doesn't have, it fills with nans, but the ones that do match, it fills with its own values. So that was concatenation. Now we could go on to merging. So merging combines 2 data frames by matching rows based on 1 or more columns. This is particularly useful for linking datasets that have a common key. Let's create a new set of data frames here. So I'm just going to copy over here some data frames that I have prepared. And again, you could pause this video to copy over these data frames so we could work on this together. And so we're going to have two different data frames. One is going to be a customer's data frame where we're going to have their customer ID and their names. And we're going to have a second separate data frame, somewhat similar but slightly different, which is going to be purchases, which is going to have also the customer ID, but it's going to tell us the purchase amount instead rather than who that specific customer is. And so we can take a quick look after we run this. We've created our data frames. We can take a quick look at customers. So that's our customers data frame and our purchases data frame. And so we have two data frames with customer IDs and their names and purchase amount. And so now let's try to merge these two data frames. The default merge type is called an inner join, which basically it returns rows where the values match in both data frames. So here we have one common column, which is the customer's ID. And using the customer's ID, where the values are going to be the same, we could merge that data together. So to do that, we would use again our PD, which is our pandas library, and we would use the merge function. And here we would provide the first data frame, which is going to be customers. Then the second one that we want to merge, which is going to be purchases. And then how we want to merge this based on what common column that we're going to be using to merge. So here we would use on as the parameter, and we would pass customer ID. And actually that's together, customer ID. And then when we run this, we have one new data frame, which has the customer ID, the name, and the purchase amount. But it only has the values that it found in both the purchases and the customers data frames. So we have 104, 101, and 103. And here we have 104, 101, and 103, but we do not have a 102. So because there's no 102 in the purchases data frame, we do not merge that into this data frame, into this new merged data frame. So it's only the ones that have in common with this specific column. So like I mentioned before, by default, this merges using what is called an inner join. So the inner join method of merging these two is the default method of merging. So this is exactly what I just described. Now there are three other different types of joining that we could use or select from when we're merging. One of these types is the outer join. So instead of inner join, which is the default way of doing it here, we could select an outer join of merging. And this basically what it does is it includes all rows from both data frames, but filling the missing values with nan. So here we could just slightly modify this and add a parameter called how. And we could pass how we want to do it. And let's say outer, because by default it's inner, inner. And this is how it was used by default, but we want to change this to outer. And then when we run this, of course, comma. And then when we run this, now we have all four of the rows, except the one that we did not have in common between the two, which was the 102 ID, that just gets filled with nans. So it gets merged, and it includes the ones that are not in common between the two data frames, but it just fills those values with nan. Another type of join that we can use is the left join, which includes all the rows from the left data frame and matches from the right. So if we change this outer to left and then we hit run, then nothing really changes because we include all the rows from the left data frame, which is the customer's data frame, and then we merge the ones that are similar from the right. So we take all these values by default, as they are. And then we try to find the values here and try to merge it into the customer's data frame. So we try to match these values to the customer data frame. Alternatively, we could use the right join. And then when we run that, then we do not have that one common customer ID, because now we took all these values, all these customer IDs as the ones that we want to include only, and then we try to merge these values into the purchases data frame. So these are all the values that we want to include, and then we take the values from here and try to match it to the purchases data frame. So this becomes the default values, and we want to merge into the purchases. So that becomes the right. We can also merge on multiple columns. And to do that, let's create a new set of data frames again. And I'm just going to copy them over here. And we're going to have a new sales info data frame and a store info data frame. And so we're going to try to merge these two data frames based on the store ID and the product. So not only does one column have to have similar values, but two columns have to have similar values at the same time in order to merge them. So when we run this, we create our data frames, and then a quick look at sales info and store info. So these are our two data frames. And so if we want to merge these two, we do pd.merge. Then we do sales info, and we do store info. And this is going to be our regular inner merge, so we'll just leave it as it is. And on the on parameter, we provide a list of columns that we want to merge on. So it's going to be store ID and product in string format. And when we run this, we see we only get 3 rows because the 4th row has dates and the 4th row here has corn. So because even though the S4 matches, the product in S4 does not match, and therefore they don't get merged because they have to match exactly as well. And so we only get these 3 rows merged together. Now, apart from merging, we also have joining. Now, joining is used to combine data frames based on their index. It is ideal when you want to align data sets using the row labels. So we're going to create 2 new data frames with sales and revenue data where the indexes represent different stores. So once again, I'm going to copy over my 2 data frames that kind of have prepared earlier. I'm going to paste them here and just pause the video and you could just copy this over and we'll continue working on this. And so when we run this, take a look at our sales data and our revenue data. So we have 2 columns, which is going to be store ID, sales, for our sales data coming from 3 different cities, which are represented as our index. And our revenue data, similarly, we have revenue, but again, the indexes are the same or almost the same, well, representing these cities. So now let's say we want to join the revenue data frame with the sales data. And to do that, we will do sales data dot join and then revenue data. And when we run this, we get our new data frame And we have only three indexes here with CH, but not with SF, San Francisco. So this joins this data frame into the sales data, but it only combines them when the indexes match. So again, we're using this set of indexes as default, and we try to merge or join these values into this data frame only where the indexes match. So the first two rows match, so we were able to add the revenue for the first two rows. But since there is no index that matches with the third row, then of course it's going to be filled with nan values. Now we could join these two data frames using, again, either inner or outer joins. So we could specify how we want to do that. And using, again, the inner joins, it will only create a data frame with the indexes that only match. So when we do sales data dot join revenue data, and we add the parameter how, we specify inner, and we run this, then we only get the first two rows because those are the only two indexes that match between sales data and revenue data. Now, alternatively, we could do using the outer joining method. And as you might think, it combines both the data frames regardless if they match. So it will have all the rows from both of the data frames, except, of course, the areas where they do not match, they will be filled with nan values. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.